So the table feature on the Inspire is not as user-friendly as we would like. So to take a look at this next group here, 12 through 14, I'm actually going to jump over to DESMOS. So with DESMOS, it's really easy to set up function notation. You can type it exactly the way you'd write it by hand. F, parenthesis, X, close parenthesis, equals, and then your function. DESMOS can also understand function notation. So turning on a highlighter here, this f of a is telling DESMOS to take the value of a and stick it into the function f. So DESMOS can compute these function values very quickly. Of course, I can't actually put -3 into this function because it's undefined there. -3 squared is 9, 9 minus 9 is 0, and you cannot divide by 0. So we want to find the limit as this function approaches -3. We can't just substitute that -3 in, unfortunately. But what DESMOS does give us is a great slider tool. So you can set that value of a to get really close to -3. I've given mine bounds of -4 to -2, and I've given it a step of 0.001. In practice, it'll actually go to 0.01 automatically, but it'll still get us really close. So what we can do is change that slider. So now I'm looking at values on the left-hand side, and we can watch, turning our highlighter back on here, we can watch these function values and see if they approach anything. So on the left side of -3, 4.46, going the wrong way there. 4.46, 4.47, 4.48, 4.49, then we go back to undefined. On the other side, on the left-hand side, if I'm looking at like 3.17 here, I've got -4.6, -4.5, 9, 8, 7, 6, 5, 4. So we can see that this function is approaching a value. It's approaching -4.5. So again, DESMOS is a tool that just allows you to really quickly find those limits. It's much faster than the table. So looking at the next function here, I want to know what happens as x gets really close to 4. Again, I can't put 4 into that function. The function's not defined at 4. But I can look at values really close to 4. Clear this highlighter real quick. One thing to note, I did go ahead and set my a between 3.9 and 4.1. When you pick those values, then your step of 0.001 does work. If you need a really accurate look at the graph, that's one way that you can get slightly more accurate numbers. Note that now I can do 0.996, 997, 998, 999, and we can see that this function is rapidly approaching the value 7 on the left-hand side. Swinging that slider to the right, you can see y values now of 7.06, 7.05, 4, 3, 2, 1. And we get closer and closer and closer until we're undefined. So this function's approaching 7. Taking a look at one last example using DESMOS. Now we have this Atari-looking logo, and we want to find out what's going on as x gets closer and closer to 0. Again, highlighted here for you, we see f of 0 is undefined, so we can't just substitute 0 in. We want to know what's happening on the left and right of that, though. So again, I've set up my slider here to go between -0.1 and +0.1. Picking really close bounds does allow my step to be 0.001. So let's go ahead and do that. So if we look slightly to the left, we see values like 0.496, 497, 498, 499 before we get to undefined. And on the right-hand side, we see 0.515, 0.514, 0.512. So we can see that we are getting closer and closer and closer to 0.5 or 1/2. One feature that I want to point out on DESMOS before ending this video, note that I'm kind of playing around with sliders and watching that highlighted number. You can let DESMOS autoplay the slider. So note that there is a play button here, and so you can watch the slider move if you like. I recommend slowing down the time if you want to do this on homework, for example. Maybe not that slow. And then you can watch those numbers. The problem with the slider, of course, is now it's going to go through every value, and here we're waiting. Now it's going the direction we care about, getting closer and closer to 0. So you can let that slider move at a speed useful for you, and you can see that, hey, we got to that undefined value, now we're on the other side. So this is just another feature that DESMOS has. It's not one I use very often, but I have had students in the past really enjoy this feature. Yep, so that's DESMOS. For the next set of 3, I do want to introduce you to a different tool. I'll go ahead and put that in the next video. See you soon.